Have you ever wondered how humanity first reached the mysterious moon itself? Imagine a moment when Earth looked up and touched the impossible dream. The story of moon landings begins with ambition, fear, and extraordinary science. Decades ago, humanity dared to challenge gravity and rewrite space exploration history. This journey started not on Moon, but within intense Cold War rivalry. Two superpowers raced beyond Earth, pushing limits of engineering and human courage. Scientists worked tirelessly, dreaming of rockets that could escape Earth's atmosphere safely. The Apollo program soon emerged as bold vision of lunar exploration success. Millions watched launches, hoping humanity would achieve something never done before then. Every rocket launch carried dreams of scientists, engineers, and entire nations behind. But success was never guaranteed in the harsh environment of space travel itself. Failures and explosions tested determination of those building early rocket systems rigorously. Yet every setback brought humanity closer to touching lunar surface reality itself. The world waited anxiously as Apollo missions prepared for historic attempt event. Inside mission control tension built with every passing second before launch day. Astronauts trained endlessly, preparing minds and bodies for unknown lunar environment ahead. The world stood still as countdown to first landing finally began. Moment. Everything humanity built for decades was about to be tested on moon mission. Millions tuned in worldwide, watching history unfold in real time, broadcast live globally. Finally, the moment arrived when Apollo 11 lifted into sky with roaring engines. Part 1 ends here, as mission journey truly begins, unfolding historic space story. NASA engineers refined guidance systems to ensure safe lunar trajectory navigation precision. Computers used during Apollo missions were primitive compared to modern smartphones today. Despite limitations, technology at that time achieved unimaginable engineering breakthroughs for humanity then. Every calculation mattered, because even tiny errors could cause mission failure instantly. Astronaut selection process was extremely strict and physically demanding worldwide for candidates. Training included underwater simulations and extreme isolation environment preparation drills constantly repeated. The goal was not just landing, but returning safely back to Earth again. Public excitement grew as launch date approached, with rising global attention quickly. Children watched rockets on television, dreaming of becoming astronauts someday in future careers. Cold War tension added pressure to already ambitious space race efforts globally. Each mission represented national pride and scientific advancement for humanity as whole. Finally, Apollo 11 launched successfully toward its historic lunar destination in space journey. Rocket engines roared as humanity left Earth for distant exploration for first time. Inside spacecraft, astronauts felt weightlessness for the very first time in space travel. Mission Control monitored every system closely during critical flight phases with extreme focus. The journey to Moon took several days of precise navigation through space. Apollo spacecraft orbited Earth before heading toward lunar orbit insertion maneuver phase. Astronauts practiced landing procedures using lunar module simulators repeatedly on Earth training grounds. Every system check ensured survival chances during unpredictable lunar descent sequence phase. Then came historic moment when lunar modules separated from spacecraft in space. Part 2 reveals deeper challenges faced during final lunar approach mission stage. Fuel calculations became critical as descent toward Moon surface began carefully monitored. Communication between Earth and spacecraft experienced slight transmission delays during critical mission phase. Neil Armstrong prepared to take humanity's first step onto Moon very carefully. Buzz Aldrin monitored instruments while supporting landing operations from cockpit closely beside. Landing sequence required perfect timing to avoid catastrophic mission failure during descent. Dust on lunar surface created unexpected challenges during final landing process stage. Finally, Eagle module touched down on Moon with historic success moment achieved. Mission Control erupted in celebration as confirmation signals arrived from lunar surface. humanity had officially landed on Moon for the first time in history. After historic landing, humanity finally stepped into new cosmic exploration era beginning. Astronauts inside lunar module felt excitement mixed with deep scientific responsibility itself. Moon's surface revealed silent landscapes unlike anything seen on Earth before ever. Every step taken created footprints that would remain for millions years ahead. Communication delays between Earth and Moon added tension to mission control teams. Scientists analyzed every transmitted image sent back from lunar surface carefully data. Dust particles behaved strangely due to lack of atmospheric resistance there present. Astronauts discovered moon rocks holding secrets about early solar system formation history. These samples would later transform scientific understanding of planetary evolution processes greatly. Public reaction across Earth ranged from disbelief to overwhelming global celebration joy. Television broadcasts brought moon landing images into homes worldwide instantly together now. Children watching dreamed of becoming astronauts, inspired by Apollo missions everywhere today. Cold War rivalry intensified efforts to achieve lunar dominance quickly then too. NASA engineers continuously improved spacecraft systems for safer space travel progress achieved. Training simulations prepared astronauts for unpredictable lunar landing conditions ahead, carefully done. Every mission detail was reviewed multiple times before final launch approval given. Apollo program represented humanity's boldest attempt to conquer space exploration challenge ahead. Engine ignition sequences required perfect synchronization to avoid catastrophic failure risk always. Launch day atmosphere was filled with anticipation and global attention growing fast. Rocket ascent marked beginning of humanity's journey beyond Earth's boundaries, forever changed. Astronauts experienced weightlessness for first time during deep space travel, amazingly real. Earth appeared smaller as spacecraft traveled farther into vast darkness above them. Navigation systems guided spacecraft using primitive yet effective onboard computers, precisely working. Mission control teams worked tirelessly, monitoring every system constantly without stopping ever. Fuel management became a critical factor, determining mission success or failure outcome directly. Lunar orbit insertion required precise calculations, and flawless execution timing needed carefully. Spacecraft separation marked critical turning point in Apollo mission journey phase now. Lunar module began descent toward Moon's surface with increasing tension building strong. Astronauts carefully monitored altitude and fuel levels during descent phase ongoing process. Moon's surface details became clearer as descent continued step by step now. Communication signals weakened slightly, causing concern among mission control engineers back home. Landing sequence demanded absolute precision to avoid disaster during touchdown attempt stage. Dust clouds rose as lunar module approached final landing position carefully now. Finally, Eagle module touched lunar surface, marking historic human achievement ever recorded. Mission control erupted with joy after successful confirmation signals arrived instantly worldwide. Astronauts celebrated briefly before beginning important scientific exploration activities on lunar surface. First steps on Moon became symbolic moment in human history forever now. Footprints left behind remain preserved due to lack of atmosphere there still. Moon rocks collected provided valuable insights into early solar formation system history. Astronauts faced harsh temperature extremes during lunar daytime and night conditions present. Radiation exposure posed additional risks for astronauts working on Moon surface area. Scientific experiments conducted expanded knowledge about lunar geology significantly for humanity progress. Each mission built upon previous successes and lessons, learned carefully, always improving. Apollo program continued inspiring future generations of scientists and engineers everywhere today. Public fascination with space exploration grew stronger after each mission's success achieved. Media coverage ensured global audiences witnessed every Apollo milestone event, live broadcast, Engineering breakthroughs from Apollo missions influenced modern spacecraft design technology today significantly. Moon landing remains one of humanity's greatest achievements in history ever recorded. Astronaut experiences revealed both scientific triumph and human courage in extreme conditions. Beyond celebration, deeper secrets of moon missions begin to slowly surface now. Many people never realized how close Apollo missions came to failure. Technical systems were fragile, relying on calculations done with limited computing power. Even smallest navigation errors could have stranded astronauts in space forever. Engineers constantly feared unknown space conditions, affecting spacecraft performance unpredictably during flight. Radiation belts around Earth posed serious risks to astronaut safety systems. Some trajectories required precise timing to avoid dangerous high radiation exposure zones. Surprisingly, Apollo 11 experienced communication glitches during critical mission phases silently. Mission control often worked under extreme pressure to solve real-time problems quickly. Astronauts trained extensively for emergencies that never fully occurred during missions. Yet backup plans existed for nearly every possible catastrophic scenario imaginable then. Public never saw intense fear hidden behind calm mission control voices broadcast. Every success masked countless near disasters avoided by split-second human decisions. Lunar landing computer was weaker than basic calculators used today everywhere. Despite limitations, precision engineering allowed impossible achievements to become reality then. Some scientists doubted whether humans could safely return from moon missions. Apollo 13 later proved space travel dangers were very real indeed. Oxygen tank explosion nearly ended mission in complete tragedy for crew. Engineers on Earth improvised survival solutions under extreme time pressure conditions. This incident revealed how fragile space exploration truly was at time. Moon missions were not just victories, but also close calls constantly. Hidden struggles included psychological stress astronauts faced during long isolation periods. Communication delays made astronauts feel extremely disconnected from Earth support systems. Some experts questioned authenticity of moon landing due to political tensions. However, overwhelming scientific evidence consistently confirms Apollo achievements beyond doubt today. Lunar samples were analyzed globally, proving extraterrestrial origin beyond any question. Yet myths and conspiracy theories still circulate decades after missions ended. These theories often ignore massive technical documentation and international verification efforts. Engineers spent years designing spacecraft capable of surviving harsh space conditions. Every bolt and wire had to function perfectly under extreme stress. Even minor failures could cascade into mission-ending disasters instantly without warning. Astronauts described Moon as both beautiful and eerily silent environment. No atmosphere meant absolute silence, unlike anything experienced on Earth ever. This silence created psychological impact on astronauts during surface exploration moments. Some described feeling deep isolation despite achieving historic human milestone success. Earth looked fragile from Moon, changing astronauts' perspective on humanity forever. This view became known as overview effect among space psychologists later. It influenced global awareness about Earth's environmental fragility significantly over time. Mission success depended heavily on teamwork between thousands of engineers worldwide. Every calculation was double-checked multiple times before mission approval was granted. Even small software errors could have led to catastrophic landing failure. Lunar module descent was most dangerous phase of entire mission sequence. Fuel levels dropped dangerously low during final landing seconds of descent. Neil Armstrong manually adjusted controls to avoid rocky surface collision impact. That decision possibly saved mission from complete failure or destruction. Moments before landing, alarms sounded inside cockpit, creating intense tension. Yet astronauts remained calm due to rigorous training and preparation discipline. After landing, unexpected surface softness surprised engineers, analyzing landing data later. Moon dust behaved differently than predicted in pre-mission geological models. These discoveries forced scientists to rethink lunar surface composition theories significantly. Apollo missions also revealed limitations of early space engineering design systems. Each mission became learning experience, improving future exploration safety standards globally. Behind every moon landing, there were human sacrifices and silent struggles. Engineers often worked day and night under extreme pressure and deadlines. Families of astronauts lived with constant fear during mission durations abroad. Every launch carried emotional weight for thousands of people involved directly. NASA teams faced unimaginable stress when even minor systems showed errors. Some engineers described Apollo work as most intense period of lives. Astronauts risked everything, knowing space offered no guaranteed survival outcomes ever. Training programs pushed human endurance far beyond normal physical limits safely. Isolation chambers tested psychological resilience under extreme loneliness for months continuously. These conditions prepared astronauts for emotional challenges of deep space travel. Many sleepless nights were spent solving critical engineering problems before launch. Success depended on coordination between scientists, engineers, and mission control teams. Even small miscommunication could have caused irreversible mission consequences instantly occurring. Public only saw celebrations, not years of exhausting preparation work behind. Apollo program required enormous financial and national commitment over many years. Governments justified cost due to scientific progress and global prestige benefits. Astronauts often reflected on fragility of life whilst traveling through space. Viewing Earth from distance created deep emotional and philosophical transformation experiences. Many reported feeling unity of humanity beyond political boundaries or conflicts. This perspective changed how astronauts viewed war, peace, and human existence. Moon missions highlighted both technological achievement and emotional human vulnerability together. Every step on lunar surface symbolized collective effort of entire civilization. Behind Armstrong's famous words stood thousands of unseen contributors worldwide. Ground control teams celebrated quietly after years of relentless dedication efforts. Some engineers broke into tears after successful landing confirmation messages arrived. The emotional release reflected years of pressure finally lifting at once. Apollo success also inspired global scientific cooperation in later space programs. International interest in space exploration grew significantly after moon landing's success. Educational systems worldwide emphasized science and engineering careers more strongly afterward. Young students began dreaming of becoming astronauts and aerospace engineers everywhere. Cultural impact of moon landing spread through films, books, and media. It became symbol of human potential and technological possibility, worldwide inspiration. However, funding future missions became challenging after initial Apollo achievements completed. Political priorities shifted, slowing down ambitious lunar exploration programs temporarily later. Despite this, legacy of Apollo remained strong in scientific communities globally. Space agencies continued developing new technologies based on Apollo lessons learned. Every modern spacecraft still carries design principles from Apollo engineering era. Moon missions also revealed importance of redundancy in critical space systems. Backup systems saved lives during multiple unexpected mission complications successfully handled. Astronaut stories continue inspiring documentaries and research about space exploration today. Emotional resilience of astronauts remains key study topic in psychology fields. Human adaptability in extreme environments was proven through Apollo missions clearly. Space exploration became symbol of courage, innovation, and collective human effort. Moon landings showed what humanity can achieve when united toward goals. Every mission built foundation for future Mars and deep space exploration. Scientists still study Apollo data for new insights into lunar geology. Technological innovations from Apollo continue influencing modern life in many ways. GPS, computing, and materials science benefited from space program advancements greatly. Human curiosity about universe expanded significantly after witnessing moon exploration success. Apollo missions remain milestone achievement in history of science and technology. Emotional stories of astronauts continue to resonate with new generations today. Their courage represents human determination to explore unknown frontiers beyond limits. Moon landing legacy continues shaping future. The moon landings did not end exploration, they started new questions. Scientists began rethinking how planets form after studying lunar rock samples. Each rock brought back revealed secrets older than Earth's own history. These discoveries changed textbooks and reshaped modern planetary science completely forever. Researchers realized Moon holds clues about early solar system evolution stages. This shifted focus from conquest to understanding cosmic origins deeply worldwide. Apollo missions also inspired development of advanced space technologies rapidly globally. New materials were created to withstand extreme temperatures and radiation exposure. These innovations later improved satellites, communication systems, and even medical devices. Space exploration became more than competition. It became shared human curiosity. The moon served as stepping stone for future Mars exploration plans. Engineers began designing spacecraft capable of longer, deeper space missions safely. Lessons from Apollo failures helped improve safety standards in spaceflight. Every mission after Apollo carried wisdom earned from earlier experiences directly. International collaboration in space science increased significantly in following decades worldwide. Countries began working together rather than competing in space exploration efforts. The moon became symbol of unity rather than rivalry amongst nations. Scientists discovered water traces in lunar regions years after Apollo missions. This finding reignited global interest in returning to the moon again. Space agencies began planning permanent lunar bases for future exploration missions. Private companies also entered space race with innovative reusable rocket technologies. Humanity's focus shifted towards sustainable and long-term space exploration strategies globally. Apollo legacy influenced education systems, encouraging STEM careers worldwide amongst youth. Many astronauts became teachers and advocates for science after retirement years. Their experiences inspired millions to pursue careers in engineering and astronomy. The moon landing footage continues to inspire documentaries and films today. It remains one of most replayed historic events in modern media. Emotional impact of seeing Earth from space changed global environmental awareness. People began realizing planet's fragility and importance of protecting it. This perspective shift is known as one of Apollo's greatest impacts. Scientists now use Moon as testing ground for deep space technologies. Future missions aim to build habitats supporting human survival long-term. Lunar mining concepts are being explored for resources like helium-3. These resources could potentially power future clean energy systems on Earth. Moon exploration may also support missions to Mars and beyond later. Apollo missions proved that humans can survive beyond Earth's environment. This realization opened doors to interplanetary exploration possibilities for future. Robotics and AI systems now assist in modern lunar exploration missions. Technology has evolved far beyond what Apollo engineers once imagined possible. Yet Apollo remains foundation for all current space exploration progress today. Each new mission builds upon lessons learned from Apollo experiences directly. Humanity continues to dream bigger because Apollo proved dreams achievable reality. The moon remains silent witness to human ambition and achievement history. Its surface still holds footprints of first explorers from Earth. Those footprints symbolize courage, innovation, and determination of entire generation. Apollo missions continue inspiring scientific breakthroughs even decades after completion today. Space exploration has become global mission shared by many nations together. The moon serves as a reminder of how far humanity can reach. It reflects both our limitations and our incredible potential for growth. Every generation inherits Apollo legacy as motivation for future discoveries ahead. Humanity's journey into space is still only at beginning stages. The universe still holds countless mysteries waiting to be discovered soon. Moon landings opened door to endless exploration possibilities beyond imagination limits. They transformed humanity from Earth-bound species into spacefaring civilization beginnings. Scientific progress continues to accelerate because of Apollo Foundation achievements. Space remains ultimate frontier for humanity. The story of moon landings continues shaping humanity even in modern times. Every new spacecraft carries the spirit of Apollo missions within its design. Engineers still study Apollo systems to improve today's space technologies further. The moon remains a destination for future human exploration and settlement. Plans for returning astronauts to lunar surface are already underway globally. This time, missions aim for longer stays and sustainable lunar bases. Scientific goals now focus on understanding moon resources and environment deeply. The Apollo program showed that collaboration can achieve extraordinary impossible dreams. Humanity learned that innovation grows strongest under pressure and necessity together. The legacy of Apollo continues inspiring young minds to explore science. Many astronauts today were inspired directly by those historic moon landings. Their dreams began whilst watching astronauts walk on lunar surface years ago. Space agencies continue building rockets far more advanced than Apollo era, yet every advancement still honors the foundation Apollo created decades earlier. The moon landing proved that limits exist only until they are broken. It transformed imagination into reality through engineering, courage, and teamwork combined. Humanity now looks towards Mars with confidence gained from lunar success. Each step beyond Earth carries lessons learnt from Apollo missions' history. The moon remains silent teacher of exploration and perseverance for humanity. Its surface holds memories of first human steps beyond Earth boundaries. Those footprints represent one of greatest achievements in human civilization history. Apollo missions united people worldwide in shared moment of wonder and pride. For a brief time, humanity looked at itself as one species. That unity remains one of moon landing's most powerful hidden legacies. Scientists continue discovering new insights from Apollo data even today still. Each analysis reveals more about Moon's origin and planetary evolution process. Future missions may unlock even deeper secrets hidden beneath lunar surface. Technology now allows precise mapping of Moon in incredible detail accuracy. Artificial intelligence helps plan safer and smarter lunar exploration missions today. Space exploration is no longer a distant dream, but ongoing global effort. Private companies and governments now work together in space advancement missions. The moon is becoming stepping stone for humanity's interplanetary future expansion. Plans for lunar colonies may one day become real human settlements. Energy research on Moon could support sustainable life on Earth. Apollo legacy continues influencing science, culture, and human imagination globally. Films, books, and education still reflect inspiration from Moon missions' history. The story of Apollo reminds us how ambition can reshape destiny. It proves that determination can overcome even gravity itself completely. Human curiosity remains strongest force, driving exploration beyond known boundaries. The moon landing stands as a milestone of courage and innovation combined. It changed how humanity understands itself and its place in the universe. Every generation inherits responsibility to continue exploration journey further ahead. Apollo astronauts became symbols of bravery and scientific dedication, worldwide inspiration. Their achievements continue echoing across time and space exploration history. The moon still waits quietly for humanity's next great return. Future missions will build upon Apollo Foundation with new technology. Humanity's relationship with space continues evolving through discovery and innovation. The moon landing remains proof that unity creates impossible achievements together. It stands as a reminder that exploration defines human identity deeply. Apollo's story encourages us to dream beyond limits every day. The journey to moon was beginning of larger cosmic adventure. That adventure continues today, with new missions and discoveries unfolding. Humanity's eyes remain fixed on stars and distant worlds ahead. The moon will always symbolize first step into universe exploration. Apollo legacy will never fade from human history or memory. It will continue inspiring generations yet to come forever forward. The moon landings showed that impossible becomes possible through unity. Humanity's greatest strength lies in curiosity and collective determination combined.